Hello, welcome back. Let's continue reading the Mikoyan-Gurevich MiG. It have this strange name because Mikoyan, that's Artem Mikoyan, that's a famous Russian aircraft designer from the Soviet Union. Artem Mikoyan, and Gurevich, that's Mikhail Gurevich, that's another engineering. They had the Mikoyan-Gurevich Design Bureau renamed to Mikoyan. I know that because I have the paper in my hands, just read about it. So, but I'm missing reading about the MiG-29 and 33 and many others. But let's read this. I think this is still flying in like Syria. The Syria Air Force have it. I had to read about it. Got the Syria Air Force. I think it's still flying there. That's the Soviet Union and this Cold War. I like to read about it, but that's very big. Maybe I should do tomorrow. To read about the Soviet Union. But let's read about this one.
Mikoyan-Gurevich MiG-21. MiG-21 Croatian MiG-21 BIS-D in-flight role fighter and interceptor aircraft, national origin Soviet Union design group. Mikoyan-Gurevich first flight 16 June 1955. U4 introduction 1959. MiG-21F status in service, primary users Soviet Air Forces. Historical Indian Air Force, Croatian Air Force, produced 1959-1985, number built 11,496, 1. 10,645 produced in the USSR, 840 in India, 194 in Czechoslovakia, variants Chengdu J7. The Mikoyan-Gurevich MiG-21, Russian, 2-1, NATO reporting name, Fishbait, ISA supersonic jet fighter and interceptor aircraft designed by the Mikoyan-Gurevich Design Bureau in the Soviet Union. Its nicknames include Balalika because its platform resembles the stringed musical instrument of the same name, Olosik, Polish for pencil, due to the shape of its fuselage, 2, and NBC, meaning silver swallow, in Vietnamese. Approximately 60 countries across 4 continents have flown the MiG-21, and it still serves many nations 6 decades after its maiden flight. It set aviation records, becoming the most produced supersonic jet aircraft in aviation history, the most produced combat aircraft since the Korean War, and, previously, the longest production run of any combat aircraft, now exceeded by both the McDonnell Douglas F-15 Eagle and General Dynamics F-16 Fighting Falcon. Development origins. The MiG-21 jet fighter was a continuation of Soviet jet fighters, starting with the subsonic MiG-15 and MiG-17, and the supersonic MiG-19. A number of experimental Mach 2 Soviet designs were based on as intakes with either swept-back wings, such as the Sukhoi Su-7, or tailed deltas, of which the MiG-21 would be the most successful. Development of what would become the MiG-21 began in the early 1950s when Mikoyan-OKB finished a preliminary design study for a prototype designated U-1 in 1954. This project was very quickly worked when it was determined that the planned engine was underpowered. The redesign led to the second prototype, the U-2. Both these and other early prototypes featured swept wings. The first prototype with the delta wings found on production variants was the U-4. It made its maiden flight on the 16th of June 1955 and its first public appearance during the Soviet Aviation Day display at Moscow's Tushino Airfield in July 1956. In the West, Due to the lack of available information, early details of the MiG-21 often were confused with those of similar Soviet fighters of the era. In one instance, James All the World's Aircraft 1960-1961 listed Fishbed as a Sukhoi design and used an illustration of the Su-9 fishpot. Design. Hungarian Air Force MiG-21 bis on takeoff. Retired Finnish MiG-21 bis on top of Verkko Kauppa store in Helsinki, Tienenmeren 211. MiG-21 bis rear. The MiG-21 was the first successful Soviet aircraft combining fighter and interceptor characteristics in a single aircraft. It was a lightweight fighter, achieving Mach 2 with a relatively low-powered afterburning turbojet, and is thus comparable to the American Lockheed F-104 Starfighter and Northrop F-5 Freedom Fighter and the French Dassault Mirage 3.1. Its basic layout was used for numerous other Soviet designs. Delta-winged aircraft included the Su-9 Interceptor and Fast E-150 prototype from Themig Bureau, while the successful mass-produced frontline fighter Su-7 and Mikoyan's I-75 experimental interceptor combined a similar fuselage shape with swept-back wings. However, their characteristic layout with the shock cone and front air intake did not see widespread use outside the USSR and ultimately proved to have limited development potential, mainly due to the small available space for the radar. Like many aircraft designed as interceptors, the MiG-21 had a short range. This was exacerbated by the poor placement of the internal fuel tanks ahead of the center of gravity. As the internal fuel was consumed, the center of gravity would shift rearward beyond acceptable parameters. This had the effect of making the plane statically unstable to the point of being difficult to control, resulting in an endurance of only 45 minutes in clean condition. This can be somewhat countered by carrying fuel in external tanks closer to the center of gravity. The Chinese variants somewhat improved the internal fuel tank layout, as did the second generation of Soviet variants, and also carried significantly larger external fuel tanks to counter this issue. 3. Additionally, when more than half the fuel was used up, violent maneuvers prevented fuel from flowing into the engine, thereby causing it to shut down in flight. This increased the risk of tank implosions. MiG-21 had tanks pressurized with air from the engine's compressor, a problem inherited from the MiG-15, MiG-17 and MiG-19. 4. The short endurance and low fuel capacity of the MiG-21F, PF, PFM, S/SM and M/MF variants, though each had a somewhat greater fuel capacity than its predecessor, led to the development of the Mount and SMT variants. These had an increased range of 250 kilometers, 155 mi, compared to the MiG-21 SM, but at the cost of worsening all other performance figures, such as a lower service ceiling and slower time to altitude. 1. The delta wing, while excellent for a fast climbing interceptor, meant any form of turning combat led to a rapid loss of speed. However, the light loading of the aircraft could mean that a climb rate of 235 m/s, 46,250 foot/min, was possible with a combat-loaded MiG-21 bis, 1, not far short of the performance of the later F-16A. MiG-21's Tumansky R-25 jet engine's specialty was the addition of a second fuel pump in the afterburning stage. Activating the RU's emergency mode, emergency. Close-up of the landing gear bay. MiG-21 at Alexotas Airport, S.Darios/S Girino, Kaunas, EYKS, MiG-21 National People's Army of GDR, August 1990. A pole-mounted MiG-21 power rating, EPR in India. Booster feature allows the engine to develop 97.4 kilonewtons, 21,896 lbf, of thrust under 2,000 meters, 6,600 feet, of altitude. The RPM of the engine would increase by 2.5% and the compression ratio would thus increase, with a rise in exhaust temperature. The limit of operation is 2 minutes for both practice and actual wartime use, as further use causes the engine to overheat. The fuel consumption increased by 50% over the rate in full afterburner. Use of this temporary power gave the MiG-21 bis slightly better than 1:1 thrust-to-weight ratio and a climbing rate of 254 meters forward/second, equaling the F-16's nominal capabilities in a close-quarters dogfight. The use of WEP thrust was limited to 2 minutes to reduce stress on the engine's 750, 250 plus 250 plus 250 flight hours lifetime, since every second of super afterburner counted as several minutes of regular power run due to extreme thermal stress. With WEP on, the MiG-21 bis SR-25 engine produced a huge 10-12 meter long blowtorch exhaust, with 6 or 7 brightly glowing rhomboid shock diamonds visible inside. The Russians gave the emergency power setting its diamond regime name, never used in India. 5. Given a skilled pilot and capable missiles, it could give a good account of itself against contemporary fighters. Its G-limits were increased from +7 GS in initial variants to +8.5 GS in the latest variants. 6. It was replaced by the newer variable geometry MiG-23 and MiG-27 for ground support duties. However, not until the MiG-29 would the Soviet Union ultimately replace the MiG-21 as a maneuvering dogfighter to counter new American air superiority types. The MiG-21 was exported widely and remains in use. The aircraft's simple controls, engine, weapons, and avionics were typical of Soviet-era military designs. The use of a tail with the delta wing gates stability and control at the extremes of the flight envelope, enhancing safety for lower-skilled pilots. This, in turn, enhanced its marketability in exports to developing countries with limited training programs and restricted pilot pools. While technologically inferior to the more advanced fighters it often faced, low production and maintenance costs made it a favorite of nations buying Eastern Bloc military hardware. Several Russian, Israeli and Romanian firms have begun to offer upgrade packages to MiG-21 operators designed to bring the aircraft up to a modern standard, with greatly upgraded avionics and armaments. 1. Production. A total of 10,645 aircraft were built in the USSR. They were reproduced in 3 factories: AZ-30, N1, 3,203 aircraft, in Moscow, also known as MMZ Znamya Truda, Gaz-21, 5,765 aircraft, in Gorky, N2, and Taz-31, 1,678 aircraft, in Tbilisi. Generally Gorky built single-seaters for the Soviet forces. Moscow constructed single-seaters for export, and Tbilisi manufactured 2-seaters both for export and the USSR, though there were exceptions. The MiG-21R and Czechoslovak MiG-21 F-13 Fishbed C MiG-21 bis for export and for the USSR were built in Gorky. 17 single-seaters were built in Tbilisi, MiG-21 and MiG-21F. The MiG-21MF was first constructed in Moscow and then Gorky, and the MiG-21U was built in Moscow as well as in Tbilisi. 1. Gorky 83 MiG-21F, 513 MiG-21F-13, 525 MiG-21PF, 233 MiG-21PFL, 944 MiG-21PFS/PFM, 448 MiG-21R, 145 MiG-21S/SN, 349 MiG-21 SM, 281 MiG-21 SMT, 2013 MiG-21 BIS, 231 MiG-21 Moscow MiG-21U, all export units, MiG-21 PF, all export units, MiG-21 FL, all units not built by HAL, MiG-21M, all, 15 MiG-21 mount, all, Tbilisi I-17 MiG-21 and MiG-21F, 181 MiG-21 UIs Del U-66 466 600, 1962, 1966, 347 MiG-21 US, 1966, 1970, 1133 MiG-21 UM, 1971 to end. A total of 194 MiG-21 F-13s were built under license in Czechoslovakia, and Hindustan Aeronautics Limited of India built 657 MiG-21 FL, MiG-21M and MiG-21 BIS, of which 225 were BIS. Cost. Due to the mass production, the aircraft was very cheap. The MiG-21 MF, for example, was cheaper than the BMP-1-7. The F-4 Phantom's cost was several times higher than MiG-21. Design. Older MiG-21 cockpit. The MiG-21 has a delta wing. The sweep angle on the leading edge is 57 degrees with a TSAGIS-12 airfoil. The angle of incidence is 0 degrees while the dihedral angle is 2 degrees. On the trailing edge there are ailerons with an area of 1.18 m2 and flaps with an area of 1.87 square meter. In front of the ailerons there are small wing fences. The fuselage is semi-monocoque with an elliptical profile and a maximum width of 1.24 m, 4 feet 1 in. The airflow to the engine is regulated by an inlet cone in the air intake. On early model MiG-21s, the cone has 3 positions. For speeds up to Mach 1.5, the cone is fully retracted to the maximum aft position. For speeds between Mach 1.5 and Mach 1.9, the cone moves to the middle position. For speeds higher than Mach 1.9, the cone moves to the maximum forward position. On the later model MiG-21 PF, the intake cone moves to a position based on the actual speed. The cone position for a given speed is calculated by the UVD2M system using air pressures from in front and behind the compressor of the engine. On both sides of the nose, there are gills to supply the engine with more air while on the ground and during takeoff. In the first variant of the MiG-21, the petard tube is attached to the bottom of the nose. After the MiG-21P variant, this tube is attached to the top of the air intake. Later versions shifted the petard tube attachment point 15 degrees to the right, as seen from the cockpit, and had an emergency petard head on the right side, just ahead of the canopy and below the pilot's eye line. The cabin is pressurized and air-conditioned. On variants prior to the MiG-21 PFM, the cabin canopy is shinged at the front. When ejecting, the SK1 ejection seat connects with the canopy to provide a windbreak from the high-speed airflow encountered during high-speed ejections. After ejection, the canopy opens to MiG-21 F-13 cockpit at the Aviation Museum in Bucharest, Romania. Allow the pilot to parachute to the ground. However, ejecting at low altitudes can cause the canopy to take too long to separate, sometimes resulting in pilot death. The minimum height for ejection in level flight was 110 m. Starting with the MiG-21 PFM, a new ejection seat proved to be very reliable and did not need the canopy to protect the pilot, which had never been fully satisfactory. The canopy is hinged on the right side of the cockpit. On the underside of the aircraft, there are 3 air brakes, 2 at the front and 1 at the rear. The front air brakes have an area of 0.76 m2, and a deflection angle of 35 degrees. The rear air brake has an area of 0.46 square meter and a deflection angle of 40 degrees. The rear air brake is blocked if the airplane carries an external fuel tank. Behind the air brakes are the bays for the main landing gear. On the underside of the